This module deals with using DAQ2GO with a variety of actuators. For the sake of review, DAQ2GO is an Excel-based electronics and software system which can be used as a system integration tool for such different applications as reviving old instruments, making new measurement systems, controlling a manufacturing process, or adding new applications to old installations. There are features available to do automation and also remote operations. This system can, of course, take, store, and treat data, communicate externally, control devices, and the whole thing is based in Excel, which makes it very easy to program. And today, I want to concentrate on controlling devices and show the way to do it using Excel. These devices really are actuators, and these things are what provide the conditions for whatever you want to happen. Temperature, pressure, and the like, for example, with heaters, chillers, pumps, and fans. Mechanical motion, be it linear or rotational, using either air, hydraulic, or electric actuators. Solenoids, motors, cylinders, things like that, connected to grippers and pushers, doors, and shutters to make things happen. There are also actuators to be put on transport systems so you can move things around or do stuff in the X, XY, or XYZ plane and make it change with time or whatever. And this includes using it with gantries, combo sliders, roller bases, and so forth. And then these can be added together to make complete integrated systems and functions, for example, for laboratory automation or for whole manufacturing processes. Now, there are just a few kinds of common actuators. There are two-position type or on-off type, such as linear cylinders and rotators, which either turn left or right, go out or in, or motors and heaters and the like that either go on or off. Then there are a variety of variable type actuators, such as those with stepper motor systems, or ones with controllable motors, and ones with actuators with position feedback. The simple type, the on-off type, with DAQ2GO are simply wired up in this fashion, like with a motor. The motor here has 110 volts to it that goes to a solid-state relay, which is the white block in the center. That block is controlled by the digital output and a power line from the DAQ2GO. And so in software you can turn on and off that motor, or it could be a heater or whatever. Similarly, actuators, for example, multiple actuators that are used for a variety of cases, will use more than one port. In this case, there's two solenoid valves that make this particular actuator move out and back and vented in each position. It's wired up in a fashion like this. The two lines are the common power lines that go to each of the two solenoids, and then the two separate valves, solenoid valves, come back to two separate ports on the DAQ2GO, and those are addressed individually to make the action that you desire actually happen. Now, the more interesting kind of actuators are variable position types. Stepper motor systems are one such. Stepper motor systems are multi-component systems comprising of a special kind of motor called a stepper motor interface which enables the motion to go one step forward or one step backward, then a stepper motor controller which requires programming to tell how many steps and how fast and in what direction, and then of course a power supply to run everything. These systems in general count the number of steps to imply what the position is, and they assume that there are no missed steps. This shows pictures of the various components of the stepper motor actuation system. There's a controller, a power supply, the stepper motor itself, then a slide onto which to mount the thing, and then a piece of software that drives the stepper motor controller. This software then is usually slaved by a second piece of software to make a true running system. and that requires adding extra drivers that drive the motor controller, and these are available in C++, in VBA, and in a variety of other languages. In summary, for some applications, they're expensive to engineer. They are, however, cheap in very narrowly defined dedicated applications. For example, scanners and printers. Now, there are other kinds of actuation that can happen where you use feedback and don't believe anything about assuming anything. And so all actuators require knowing something about the position. So usually there's a home switch to set for 0. Then with a stepper motor you assume there's no steps and you count everything from where that switch was. And so that's the number of steps is equal to the distance, and the frequency of the counts is the speed. There are other actuators that actually use a true distance signal, and these kind of signals can come from pulse type encoders, quadrature, which is another pulse encoder, string pots, or geared potentiometers, or LVDTs and the like. These all vary resistance when the distance changes. Now, when these are fitted to these DC actuators, there's a very interesting thing that's happened. It's a recent addition to the market, and you can control the speed and force with DC directly. You always know where you are, and these are inexpensive and simple to apply. Here's a picture of one that shows a white surface that can go back and forth, located here, and then the motor is all integrated in it, so it really is a slider and a motor and everything all in one. And then it doesn't assume anything. It has a built-in potentiometer which varies resistance with position. So this is connected up to DAQ2GO, for example, with a variable power supply on the side and an analog input on the side. And then you know where it is and you can tell it how fast to go and stop and so forth. Here's actually an application of that where the device itself, is set up to go back and forth and do compression testing on an elastomeric sponge kind of material. Another application is retrofitting a whole instrument that's a extensiometer that can stretch a spring and record the force that it takes to stretch the spring and do it at a controlled speed. This, of course, has a complete user software and interface and the like, so it's a traditional instrument. If you now turn to the software section for that, all of these interfaces, the digital, the analog, the RS-232, all of the virtual COM ports are all readily controllable from an Excel spreadsheet. The Excel spreadsheet kind of looks like this. It's under a tab called Control Sheet. The headers here tell you each of the kinds of interfaces that can be controlled, and then one can choose to either use a dedicated controller like a PID control here, or change it so it's a user-controlled behavior, in which case you put in whatever function you want associated with this cell down here. That cell can either be some user-defined function by itself or point to other cells, and this can wind up being an equation with branches and if statements up to 7 deep in a single cell. So overall, you're really looking at DAQ2GO as a complete Excel-based integrated electronics and software system which can be used for reviving instruments, making new ones, doing manufacturing processes, anything for automation, anything where you want to take in data and control processes.